Hello and welcome to the CABE webinar for Thursday the 23rd of July. Today we are looking at how you can be BIM ready for a post-COVID worksite with Ronan Collins. My name is Jordan, I'm the Regional Services Administrator here at CABE and I will be the moderator for this webinar. So we do like to make our webinars interactive, so please do send through any questions and we can go through these at the end with Ronan. You can do that by using the little question panel that should appear on your screen, or you can tweet us or send them through to the info@cbld.com email address. I can always send them through to Ronan outside of the session if we do get a lot of questions. So I'm just going to bring in Vivian and she can go through the Hong Kong office.
Yes, thank you, Jordan. Dear CABE members, good evening. It's Vivian, General Manager of CABE Hong Kong Chapter. CABE Hong Kong Chapter has been set up early this year with the following aims. First, we support and ensure proper governance and operation of CABE chapters in the Asia-Pacific region, including monitoring and reporting of compliance to CABE standards. Second, we help raise the profile and influence of CABE in the region with the industry and government through representation to local government authorities and other professional bodies locally. Third, our office set up is to provide front of office function for CABE headquarters in the Asia-Pacific region, including membership recruitment, upgrading and renewal, facilitating membership and chartered engineer interviews locally, liaising with local academic partners, communications with members on behalf of the chapters, disciplinary matters, and promotion of CABE Benevolent Fund. Last but not least, we are committed to delivering quality local activities, including regular committee meetings for each chapter, regular CPD sections to members, annual chapter AGMs, conference, and other formal events. The CABE Hong Kong chapter is led by Mr. Kieran C, and you can see his background and accomplishment in the society on the PowerPoint slides. I will support and look after the daily operation of Hong Kong chapter for CABE. May I move the next section to the Jordan? Thanks.
Thank you, Vivian. So next up, we have Alexander joining us from Trent Global. So I will just hand over to him if he would like to turn his mic on.
Yeah. Hi, everyone. I'm Alexander from Trent Global. I'm the Business Development Manager over there. So Trent Global has been providing quality education for the last 15 years, and we have over 3,000 alumni within the built environment industry. Our courses range from facilities management to construction. We're incredibly happy to have partnered with CABE for this BIM webinar, and we're looking forward to hold more webinars with CABE to benefit the built environment industry. So for today, Mr. Ronan Collins is also will be teaching at Singapore's only Masters in BIM that is going to start in September, and there's an intake in January as well. So for the Masters in BIM, it's 100% project-based. As you can see on the slide on your screen, these are the 5 modules that will be covered, and there is a dissertation that's part of the module as well. So for this Masters in BIM, it aims to gather different industry leaders from different domains within the built environment industry to be equipped for the digital age in building. So we're currently running a promotion of about $1,500 Singapore dollars discount if a candidate were to sign up by the 15th of August for this Masters program. So I'm just going to put the link for the Masters program in the chat over there. You can have a look at the program outline. Definitely, if you like today's session with Rowan, it's going to be like that for the Masters program. I guess a bit more intense, but yeah. I'm also going to put my number in the chat So feel free to contact me if you have any questions about the Masters in BIM. That is the only Masters in BIM in Singapore. So yeah, thanks guys. Yeah, these are the courses that we do in Singapore.
That's great, Alexander. Thank you. So I will now introduce you guys to Ronan Collins. So he is the gentleman providing the webinar today. So he is a passionate individual committed to driving innovation and digital transformation in the construction industry in Malaysia. As a professional with more than 10 years of experience in implementing digital solutions for large-scale developments, Ronan will be providing expert advice and practical insights on the implementation of BIM processes and how to get the maximum value from it. So, Ronan, I'm just going to hand over to you now.
Thank you very much. Good evening, everybody. So just a quick check. Can you guys see me and the slide? Jordan, can you quickly confirm?
It's saying that we are currently waiting to view your screen, so it might just be loading at the moment.
Oh, hang on. Why is it asking me for a screen? Bear with us here for a second while I figure this out. Show my screen. Oh, hang on.
There we go.
Okay, right. Success. So very welcome to everybody this evening. I'm coming to you live from Kuala Lumpur in Malaysia, and it's my pleasure to be here. This is a review of a presentation I gave a couple of weeks ago to the school in Singapore, where they covered the title BIM there, done that. So the title for this evening's presentation is How Can You Be BIM Ready for a Post-COVID Construction Worksite? So a little bit about me first. This is my son, Michael, and my beautiful wife, Wiley, and we're now living in Malaysia for the past 4 years. Michael was born in Hong Kong, where I spent 16 years, and I'm now working for Gamuda, which is a very large civil engineering contractor here in Malaysia. And just let me do one thing here real quick. This should work. Yeah. So the best way to keep in touch with me and find out what's going on, all things BIM and all things technical, is to find me on LinkedIn. So at the end of this presentation, I'll give you a link to my LinkedIn profile. You can follow me, you can connect with me, and I'll be very happy to take questions. And it's a very good way to keep an eye on what's going on. So I'm sure some of you found out about tonight's course from that method. And the other thing you can do, and this is something for food for thought, how many people here have a YouTube channel? And how many people have actually uploaded a video either of something to do with work or something that they're passionate about or something they're interested about, and actually learned how to do some communication and sharing? So if you're able to produce a video, then YouTube is a very good way of sharing it. And don't expect to have thousands or hundreds of thousands or millions of views. If a few people can see your presentation, then all the better. So I'm very happy when 50 or 60 people see one of my presentations. If you would like to see some of our past work, we've maintained the original IntelliBuild Hong Kong YouTube channel, and that's got some interesting material on it. So if you'd like to see that, look that up as well. So that's a bit of the background about myself. I'm going to set the scene for this presentation in a very simple manner. Today, it's the 23rd of July, 2020. 90 years ago, they built the Empire State Building in New York. And you're all probably thinking, well, what's that got to do with BIM? So the Empire State Building in New York is over 100 stories tall. It's still one of the tallest buildings, if not the tallest building in New York. The design, the planning, and the construction of this building took 20 months from start to finish. Question is, could we design and construct this building today in 20 months? And I would argue probably not. The construction was moving at such a rapid pace that in one period of 10 days, the builders created 14 floors. 14 floors in 10 days. When I was working in Hong Kong, if we could do 2 floors, if we could do 1 floor in 2 days, we were quite happy. And the most important thing when you read about this building is that speed, that accelerated construction process, while it was part of the heated who can build the tallest building in New York first phenomenon in the 1930s, it was made possible through precise coordination of the building design, as well as the mass production of steel frames and windows and many other elements. The precise coordination of the building's design. Do we in 2020 have precise coordinated building designs when we start construction? I would tend to believe not. And how much of our buildings are mass produced off-site? And I would argue not enough. So when we talk about the post-COVID-19 phenomenon, we need to look back through history and see what's going on. So let's have a quick look back at what we've achieved in digital engineering, BIM, virtual construction over the last 15 years. And then I'll give you a rundown of where we're going in the next 5 to 10 years. So my journey began in 2003, earlier than 2003, even doing 3D modeling and construction sequencing. So around 2000, I started using Tekla. 2003, I was using things like Rhino and CAD. Come 2006, 2008, we were getting into things like Revit. 2006 through 2010, we designed and built the Cathay Pacific Cargo Terminal. So that building finished 10 years ago. It started 15 years ago in Revit. Then we did the Hong Kong MTR projects. And then from 2010, 2015, we did the big midfield concourse at the airport, and now the airport in Hong Kong is going through a massive development phase. In fact, I noticed on LinkedIn 48 hours ago that they were actually talking about a digital twin for Hong Kong International Airport. So if you want to learn more about what they're doing in Hong Kong Airport, look them up on LinkedIn. And then from 2016 until now, I've been heavily involved in the Line 2 project for the MRT in KL. So this is an outline of what we're going to get through this evening. We have got about an hour, and I do welcome questions. So please do put in some questions into the question box or even in the chat box. But as you think of questions, ping them up. There are no silly questions in the world of BIM and digital construction. So the first ever BIM project, and this is before the term BIM was even coined. You have to go all the way back to 2005 in Hong Kong. And this was a school. This was the Canadian International School, and they were wanting to build a world-class musical and auditorium facility for the students or the kids. And we were working with the architects, the engineers, and the owner to do a verification of the design using 3D models. So everything was designed using 2D drawings, and then we built these 3D models. So this is a cross-section to the building. And then we looked at the construction sequencing. Because of the nature of the site, it was a very complicated site, very steep. So we built a 3D model of the temporary works. We built a 3D model of the existing site. And then we built a 3D model of all the foundations. Now, this was done in 3D CAD. So this is all pre-Revit. Revit wasn't even kind of written at this point. So this is so long ago. But it just demonstrates to you that building 3D models, if you're not building 3D models in 2020, you better start figuring out how to build them. You can't turn around and say in 2020 that, oh, it's too hard, or it's a new technology, or I don't know how to use the tools. You need to learn these tools, and you need to learn how to use them and make value from them. We even did the MEP models for that particular building. So we modeled all the ductwork systems, we modeled some of the fire sprinkler systems. It looks rudimentary, it looks quite basic, but it was still done, and it demonstrates what's possible. Now, moving on, a couple of years later, we did a very large project in Macau, and some of you may recognize this if you're familiar with Macau. This is the City of Dreams, and the City of Dreams was built, designed, and put through in a very short time frame, but we relied upon BIM to do some of the coordination. Now, in preparation for this presentation, I actually went back and I found one of the models. So this is actually AutoCAD MEP and Tekla structures, and a little bit of AutoCAD architecture. This is pre-Revit, and it shows you that a model that was built some 10 years ago, even now in 2020, we can actually go into that model and we can see the detail of the model. So it's worth bearing in mind that models and information that you're generating now, the way these technologies work, they'll still be available to owners, future architects, future engineers as they go back and rebuild and look at these projects. So this gives you a sense of it. And I'm just going to pick a grid line here just to show you what this looks like in section. So like all these casinos, there's a very large area in the middle. I can't get into too much detail for lots of good reasons, but I just want to show you one feature of this casino. So in the casino, there is a exhibition space, and it's a spherical space. So I'm going to do, oops, what am I doing here? For this one. I gotta remember how to use Navisworks. So you can see, even in a model that far long ago, we had all the mechanical systems, we had the structural systems. But the problem with this particular part of the building was we had to design this spherical shape we had to design the supporting structure around it, we had to design the MEP around it, and we had to design the glazing system on the outside as a feature. So you can see here that this model is, relatively speaking, quite straightforward. So what I'm going to show you is I'm going to show you how we did the coordination of that model. So let me just quickly bring up, I'm going to find the right one. Should be this one. Just bear with me 1 second. I'm working on 2 screens, so things are going to pop in and pop out. So this is what it looks like. This is a presentation actually from back then. So I'm going to show you the actual geometry. So this was the architect's design for what was called the bubble. And you can see in the middle of the screen, the kind of spherical shape with a slight distortion at the front. And you can see how it fits into the kind of main entrance area for the actual development. And as far as I know, it's still there. When you cut a section through it, you can see the external elevation, you can see the basement car parking, and you can see the complexity of the shape. So in order to design and construct this, we had to use parametric modeling. Now, parametric modeling is a rule-based modeling, so if you make changes to certain features, the whole model will change in relationship. So this is an initial geometry model in Rhino. And then when we get into the detail of it, I can skip this for a second. We then moved into using what became known as Geary software, which is the same software that we use for the airlines, which is CATIA. So this is actually the CATIA software. And CATIA was used to come up with all of the structural elements inside this complicated geometry. And because CATIA is parametric, we could do all this calculation. So again, this is just a demonstration to say that there's nothing new in the world of BIM that hasn't been done in the last 10 or 15 years. And you should be able to find some of these examples either through these kind of presentations, by contacting people like myself who've done it, by finding out how to do it yourself. The information is there. Now is a good time to go and learn how to do some of these things. And what's great is when you go and look at some of this information from all those years ago, we were using these models for quantification. So one of the things that we're struggling with in the industry right now is how do we actually use the information in the models for pricing? How do we use it for variations for value engineering? We were doing the same thing before. We were looking at areas. We were trying to calculate geometry setting out. So we were using the models to take the model from the actual digital world into the site world. So we were providing all the setting out to the guys on site. And we were actually using the bigger model of the actual structural steel for all the quantification. So we knew, as we were doing the detailing, how many tons of steel we had. We knew what sections we needed to order. We knew what the lengths of those sections were going to be. So we had quite a lot of information available to us even back then. Now, it's worth bearing in mind when we were doing these projects 10, 15 years ago, they were at the front of the industry. They were cutting edge. They were pushing the limits. It wasn't the normal. But in my opinion, by now, the industry should have caught up. And you have to ask the question, why is this not normal in all of our projects? If we could do this 15 years ago, why can't we do this today? So this is what we should be thinking about in terms of post-COVID-19. Now you're going to see me jump around to the next part. So we go back here. And then the next one I'm going to speak about is probably the first true BIM project that we got involved with, which is the Cathay Pacific Cargo Terminal. And the Cathay Pacific Cargo Terminal was actually, there was a requirement in the design specification by the owners, Cathay Pacific Cargo Services, to design and coordinate this building in 3 dimensions, which was a precursor to BIM. And then when we went to construction, the models were provided to the contractor, and the contractor was a joint venture between Gammon and Hiping in Hong Kong. And it was them working with Siemens and Lodica doing the cargo systems that had to coordinate this project. So let's have a look at the details of this one, which is here. Oops, get that one to pop up. Just bear with me 1 second. There we go. So this is another cross section through it. Now this building deservedly was modeled in 3D because I don't know how on earth you would coordinate it using 2-dimensional drawings. It's so complicated. So there's many layers. There's many interfacing layers. There's many secondary systems. There's many access systems and fire systems, et cetera, et cetera. So it really begged to be modeled and coordinated in 3D. So let's have a look at some of the details and let's look at some of the lessons that were learned. This was our first use of Revit structures, and we modeled with the Barnhart engineers and the ADAS architects all of the structures in Revit. And the mantra here was to model first and draw second. So our objective was to use the Revit software to produce as many drawings as possible, but our real objective was to coordinate the design. So here you can see a snapshot for those of you who know Revit. This is actually Revit Structures 2008, which means it's a 13-year-old piece of software. I wouldn't like to have to use it now. It's a lot better now than it was all those years ago. It had a lot of limitations, but it still was a powerful piece of software. And we used it for this kind of documentation. So we used it for doing the detailing for the frames. We use it for laying out all the double T's. And this is what it looks like back in the models. So again, when we built the models, we tried to be smart and put in the names, what the double T sections were, what the inverted T sections were, so we could get information from the models. Now, we did not use this model for quantification. We used it mainly for coordination. And you can see how we've done that. This is the architectural model. So there's an office building in a corner, and then you have this massive warehouse. If you have flown into Hong Kong, you will have noticed this building. It's impossible to miss. It's huge. And then on top of the architecture and structure, we did all the MEP modeling. So you can see here an example of the MEP framework. So you've got pipework systems, cable tray systems, and mechanical systems. So again, this is a very good example of a 3D MEP model that was done for coordination purposes. So this is one lesson that you can do it. Second lesson is, did we have enough detail in the design model for the construction? Could we live up to the Empire State Building of a precise, fully detailed design? The short answer was no, not really. So let me explain why. We were using the model to produce design drawings, and we were going to use it to produce construction drawings. But the design drawings were being produced by us and the design team primarily to meet the normal standards of the industry. In other words, to provide enough information for a contractor to price a project, but they would have to go further to do detailed shop drawings and fabrication drawings. So it was effectively a reference design, if you want something a better description. But it was a very well designed, very well detailed set of plans, but they were design drawings. And there's the software that we're using: Revit Structure, Revit Architecture, AutoCAD MEP. And then, oops, go back up here. This is just to demonstrate something else. If you're living in Hong Kong, they're now talking about using ISO 19650 BIM standards. And if you're in Singapore, you've got the BCA standards. In Malaysia, we're using PAS 1192 and ISO 19650. All of those standards are based on one simple principle, that you have a server. In our case, it was actually a local area network, not a cloud, but now it's all gone to the cloud. That you have a server where you have working information, in our case, drawing production information, and you have published information, which is information that's shared. The same principle applies today as it was when we did our project. It's on a server, it's shared between the design teams, and then it's published when it's approved. And we were publishing PDFs and DWS. We were using a structured folder structure. Now, this is quite a basic folder structure, but you can see we had a live working environment and we had a published environment, which is what the current standards all require. So you have two-dimensional drawings, you have three-dimensional CAD files, you've got your clash analysis files, and you've got your native Revit models. So all of this information you can see was properly named, so we could tell by the naming convention which project it was, which type of file it was, which discipline it was, and then we could tell what level of the project we're looking at. So we did have a file naming convention. The modern file naming conventions are slightly more complicated, but it's the same principle. Everything was structured in terms of information, and everything was controlled in terms of the naming. Crucial part of the world of BIM as we see it now. And you can see we had somewhere in the region of 3,000 drawings at the design stage. So this is a typical example of what one of those drawings would look like. Lots of color, each system has its own color. And the beauty of Revit is that you can draw a section wherever you want. So if you've not used Revit before, one of the key features of Revit is it does very, very slick drawing production, and you can produce quite a lot of drawings and quite a lot of detail if you know what you're doing. And this is what those sections would look like. So you can see the structure, you can see the building services, you can see the access ways, etc., etc. And you can probably argue on scrutiny that they weren't the best drawings in terms of line types and hatching and where lines meet. But for the first editions of Revit, they were pretty good. Now Revit's got very, very slick. So producing drawings in Revit's actually quite easy. Now this is a graph that will become a great part of our training when we get into Singapore in the BIM process. This is a clash detection matrix. This is a graph that I produced. It's been reproduced on many, many projects since. I don't claim to have invented this process. I think this is just an image that makes it very clear. The objective here is that you identify the critical elements from the client's perspective and operations perspective, and then you drill down through the structure, the architecture, and eventually the MEP. So you're working through a process of identifying what are the highest priority coordination issues and what are the lowest priority coordination issues. And that hasn't changed in 20 years. And this is how you can use the software. This is Navisworks. You can run automatic clash detection. It'll find all the issues. You can categorize all those issues, and then you can get to see what they look like. So you can see, well, there's a problem. There's a ductwork clashing with some concrete. We got to get that fixed. And here is the key part of this particular presentation. This is now the contractor raising queries using the model for the detailing of all the concrete. And they're starting to identify where the modeling has not been completed or has not got to a certain level of detail. So in this case, the model demonstrates the size of the beam between the grid lines, and it demonstrates all the beams coming into a connection. But because this is a complicated movement joint, the detailing by the designers doesn't include all the fine detail of where the corbels will stop and where they'll meet. And another issue we've discovered, and this issue is still relevant today as it was back then, in these large infrastructure projects, the designers will typically model the structure as being flat. In other words, they won't allow for any falls, any kind of cross falls, because that's something the contractor will pick up in the shop drawings. But when you start modeling in the falls, you start to realize that every one of these connections is slightly different. So you have to account for all that when you actually start doing your concrete pours. So you can see that there's a fall on the edge beams, and then there's a cross fall on the secondary beams, which leads to some very complicated joints in this detail. So this is where we discovered that the cope or the joint at the end is not square. So it's just using the model from the construction phase to show us the detail. Now, the lesson learned here is that ideally, you want to get the contractor involved as early as possible for them to bring this level of expertise into the design team. Or you need to get them as an advisor to get the models to this level of detail. But the trend hasn't changed. The design engineers' models and the engineers' information is still going to be suitable for information for tendering and for construction for the contractor to take forward detailing. In order for BIM to be really successful, you need to get to that level of detailing. You've got to get to that much higher level of detail to find the real issues. And I'm going to skip to this. And this is just a picture of what it looked like on site. So this is the actual project during site. That's just there for happy memories more than anything else. So where do we get to? Cathay. So that's the Cathay cargo example. So that's back in 2008, 2010. So that's 10 years ago. And then we're going to go and look at something a bit more recent. Again, this is a Hong Kong example. There'll be one in Singapore soon enough. This is the midfield concourse. This was, again, designed in 3D by the design consultants. So this was an Arup, ADAS, Mount McDonald design team, and they did a pretty good job at the design. Quite an interesting design, in fact, the way this is done. And then they provided the models to the contractors for the construction stage. So again, I'm going to show you some of the challenges of going from a design model to a construction model, and some of the things that you need to be watching out for as more and more people start using models for design and for construction. So we're going to come all the way back down here to the next PowerPoint deck. And some of you are PowerPoint aficionados will say, well, hang on, why have you put all these slides together? So I haven't had the time. So let me very quickly show you this. This is the overall slide deck, and it goes through exactly the same as I've shown you all the other projects. So on this project, we were modeling the structure, the architecture, all the building services. We were using the model for coordination. We're using the models for drawing production. And the one thing that I want to share with you from this project is the geometry on the roof. So I'm going to show you the roof surface and how that was designed. Just bear with me here. That to go down there, out of the way. Oops. I'm going to get this. Don't forget, if you got any questions, ping them into the chat boxes. I see a couple of questions coming in. Okay. There we go. Let me just check something here. Yeah. I presume you guys can see me because somebody hasn't been told me otherwise. So what I want to talk about here very quickly is this geometry. So what we're seeing now is because the software is becoming so powerful and so useful, architects are becoming more and more creative with their designs and somewhat organic. And here's a challenge when you do that. So these roof systems particularly, there's a huge emphasis on the contractor doing the detailing. So you may have a very specialist contractor who can do the detailing for these kind of roofs. So rather than the architect trying to second guess or outguess the construction industry, they come up with a performance specification and an outline design. So in this example, they provided the surface geometry, and the surface is very well defined. So you can see all the different colored surfaces. All those surfaces have got geometric definitions in terms of radiuses setting out. So you can see all these different curves. And this is the definition for the roof surface. Now, this is critical for the airport. If this roof ends up too high, it will actually block the line of sight between the air traffic control and the actual planes. So this roof geometry is critical. But the challenge is it's not detailed enough. So when it comes to doing detailed coordination, they've managed to produce a surface, and you can see it here, this kind of beige surface. This surface is the architectural top surface. This is what the roof has to be designed to. But apart from a single gutter along the side, the surface doesn't allow for the gutters along the back of these skylights. It doesn't allow for access ways through the space, and it certainly doesn't allow for the detailing of the steelwork. So let me show you an example of what I mean. So using the architect's surface, the engineers have developed the geometry for the roof steelwork, and they've done a reasonable job. So you can identify the primary trusses, you can identify all the primary structure, you can see where the posts are going to go in for the cladding systems, and you can start to see the outline of what is supposed to be a walkway for access. That's the design model, and this is the fabrication model, pretty much taken from the same position. And there's a stark contrast and a stark difference. The biggest difference is all of the connections required for the actual roof systems, but also all of the secondary steelwork that was not in the design. So if I go back up one, so you can see here, like for example, along this elevation, there's a lot of steel that wasn't modeled at the design stage. It's considered secondary steel. And when you model it in, there's quite a lot of steel work involved. So the challenge when you're working on these projects, particularly if you're a contractor, is to understand what has been modeled by the consultants, and more importantly, what has not been modeled, because that still has to get modeled, it's still got to get coordinated. So there's a lot of lessons to be learned from these projects in terms of, well, we know what the consultants are more than likely going to produce, but what do we have to produce to actually construct this building? And then when you add in the next layer of complexity, which are these pink blocks for the access walkways, and then you start to see the ceiling systems underneath, and then you start to see the actual roof cassettes. This is a structural system with the acoustics beneath the cladding system. You start to put in the walkways. This becomes a very complicated thing to coordinate, and it led to many, many meetings, many, many RFIs, many, many discussions, a lot of changes in terms of structure, a lot of changes in terms of geometry, but eventually it did get built. It turned out to be a fantastic building. But when you start to look at this from underneath, just getting the cladding system onto the building was one challenge, but to actually coordinate all the building services in the space and then to coordinate the ceiling in the space was also an exercise. So the contractor elected to do all of that in 3D using BIM processes. So all of the mechanical systems, these were all modeled by the mechanical contractor. So the lessons that we learned on the Cathay cargo terminal was to actually get the mechanical contractors involved in the modeling process, and they would model where they wanted the ductwork, where they wanted the pipe work, where they wanted the cable trays. And they would work with the steel fabricator to make sure that it was all coordinated. So what you're looking at here is actually a model that was developed by 3 different contractors or subcontractors, depending on how you look at it. There's the steelwork contract, which was all done in Tekla. There's a roof cladding contract, which was done in Tekla. And then there's all the mechanical electrical systems, which are all done in Revit. 3 different contractors working on 3 different programs at 3 different schedules, a real coordination channel. And then beneath all that, you have a ceiling grid. And the ceiling is a very complicated grid of triangulated panels. I can't remember the specific number, but there was a huge variety of panels. Some of them were perforated, some of them were solid, some of them had penetrations. I think there was over 1,000 different types of panel that had to be slung into the ceiling. So one of the challenges we had, and it's still a challenge today, how do you go from 3D CAD or 3D BIM or digital engineering models and relate that to site? Now, this was less than 10 years ago. Probably 8 years ago. So how did we link what was happening on site back to the models? So what we actually did was we actually invested into laser scanning. So I'm just going to show you how we did this. So we actually scanned on site all the steelwork as it was erected. And you can see it here, this green blurb. And we actually used the laser scan to compare to the actual fabrication models. So we were able to compare what was happening in the site to what was actually designed and detailed. So we were able to tell if the cords for the trusses, which were in between the ceiling panels, were in tolerance and into specification. So again, another topic for learning is going forward. You need to understand how do you verify what's on site and compare to a model. Now you have more and more technology available. You can use your iPhone or your iPad. You can take photographs and create 3D models of photographs. You can use augmented reality, so you can actually bring the model to site on your iPad, and you can actually look at it through your screen and see where the model is in relation to site. And you can do this very detailed laser scanning. I'm not going to get into the pros and cons of each, it's a lecture in itself, but again, we could probably set up as a separate conversation. But I want to quickly show you one of the benefits we learned about using laser scans. So these are the actual air bridges or gantries. And in order to cover these in cladding, we had to measure all the connections on site. So we laser scanned all the gantries. And what we were looking for is we were measuring for each of the connection plates, how much out of tolerance they were, where the slotted holes were, to make sure that we didn't have to make any adjustments to the cladding system rails so we could quickly erect the steelwork on site. So this is one really good example of where you can use the laser scanning to verify the shop drawing details to make sure it's in tolerance for the next phase of works. And I'm not going to go into the airfield use services. So that's where we got to with the midfield concourse. Again, it shows you one of the challenges of working between the actual site and the construction project. So we're getting up to a bit closer to real time, and I want to quickly show you some of the solutions. So we've talked about BIM in terms of building information management. Virtual reality is something I'm not, I've got some experience on, but I have found limited use, particularly on construction sites. It's very, very powerful for design reviews. Augmented reality is an absolute breakthrough technology. We're using it on 10 of our sites right now, and we're taking Revit models onto the sites on the iPads, and we're using it to verify rebar, we're using it to verify cast-ins, we're using it to verify MEP systems, and we're using it to verify a lot of the works on site. So augmented reality is something you definitely need to figure out and learn. But you can't do augmented reality if you haven't got proper detailed coordinated models. Drones is a topic unto itself, which I'm going to touch on. Photogrammetry is the conversion of images into models. So you can either use context capture from Bentley, or you can use Recap Pro from Autodesk, or a number of products like that are out there. You can use laser scanning, which is very, very fine detail. 3D printed models are great for doing modular testing. And then you've got all the other stuff at the bottom. Now, robotics, data analytics, AI, and machine learning are the bleeding edge of construction in 2020. So I showed my wife last night a picture of the latest Boston Dynamics robot dog carrying a Leica scanner, walking around a construction site fully automated. Robotics are coming, and they're coming fast, but at $50,000 US, one of those dogs is too expensive for most projects in Asia. Data analytics is something I'm working on a full-time basis, and AI or machine learning is coming, but not quite there yet. So we'll see how it goes. But regardless of what technology you're thinking about using, there is one golden rule. You need to figure out in the post-19 or even the post-COVID-19 environment, what is the problem I'm trying to fix? What's the scale of the problem? How much is that problem costing my project or my business? And then you need to go and look for a suitable solution. Too often we see people going to a presentation like this going, oh, I saw Ronan, he was talking about laser scanning. I'm going to go and buy a laser scanning equipment. But you need to understand what the problem is that you're trying to solve. So on the construction site on the airport, we were trying to solve a surveying problem in very complicated access areas. In the work we're doing now using augmented reality, we're trying to solve a problem where the sites are very dynamic, and we need to make sure they're checking the right information. So we have always defined a problem. Well, not always, but that's now our rule. We now define the problem, and then we go and find a solution. So let's bring it right up to today. This is the KVMRT Line 2 project in Kuala Lumpur. This is a massive project. This is a 52-kilometer alignment through the city of Kuala Lumpur. This is the second line that's been built in the last 6 years. And the section that I was working on is the underground section. It's a design and construct contract led by the MMC Gamuda contractor, with AECOM as the lead consultant, with a multitude of other consultants in support. It involves the construction of 13 kilometers of twin bore TBM-driven tunnels through the city, which is a mixture of Kenny Hills soil, which is a compact soil, and karst limestone, which is a treacherous ground condition to mine in. There are 10 underground train stations, and all of the stations, all the tunnels, all the ancillary structures were all designed and modeled in Revit. And then the models were used for coordination, for design documentation, for construction documentation, and are now being used for all the MEP installations. So this is just one of these 10 stations. It is at Titiwangsa. This is the architectural model in Revit. So you can see that first rule, only model the Revit architecture. Then you've got the structural model. So this is all of the D walls, all the structural information. And then this is where this technology comes into its own. Inside these station boxes are some very sophisticated, very complicated building services systems. So here you can see the mechanical systems, electrical systems, drainage systems, and in the background you can even see the tunnel systems coming into the stations. And the only way to coordinate this, in my opinion, is in BIM. There's no other way of doing this unless you've got thousands of staff and thousands of hours. The models also include all the operating train systems. And then this is a federated model. This is level 2 BIM as defined in PAS 1192. This is a federated model. This is all of those systems in a single digital environment, and all of the information for the systems is included. So if I was to click on any one of these elements, you would be able to determine what it is, what it's been designed to do, and what it's intended to be specified as. You can use these tools to cut cross sections so you can see the depth of the station. So this is a classic implementation of BIM. The only difference between this project and the previous ones is this has been driven by an information protocol, which I'm going to get into in a bit more detail. So on top of doing BIM for modeling, on top of using BIM for drawings, we also wanted to use BIM for asset information or asset data capture. So this is the actual use case for BIM on this particular project. So during the phases of designs, from preliminary design through final to construction into final CSDs and as-built, all the normal stuff, visualization, design authoring, which is modeling and drafting, doing virtual design reviews and coordination, clash coordination, and then asset data capture. So the lesson that's been learned on this project is all about information management and data capturing. So let me show you some of the things that we've learned. And I'll skip that. So this is a classic example of one of those models. This is just a snapshot of the same thing that I showed you in the video. So the first thing you have to do is you have to change the culture of the teams. And the first thing that we did on the underground was we took a lesson, actually it was a lesson that we'd learned back on the Cathay cargo terminal. We co-located the teams. So the engineering teams were all set up in an office in Kuala Lumpur with all the major decision makers in that office. So the architects, the structural engineers, the building service engineers, and the contractors technical team were all working from the same office. So it was very easy to get everybody together and do a review. Second thing we did is we drove all the reviews through models. So all the design reviews, all the coordination reviews were driven by models. And in a lot of cases, we would have a representation from the client. So this is Mr. Yap from MRT. He's actually an interface coordination engineer. He was attending some of the meetings. This is Chi Heng from the AECOM lead team. And actually Chi Heng and himself are now working in AECOM in Singapore. So if you want to get a coffee and ask Chi Heng if this presentation is true or not, then look him up in Singapore. And then the rest of the team here from the engineering consultants. They're reviewing the models. And what they're doing is they're following this process. Sorry, someone was blocked out by my big ugly head. But we have a coordination process where all the models were checked and then coordinated. And what we're doing is we're looking for coordination issues. So this is the low-hanging fruit. This is the easy part of BIM. Check if one model is coordinated with another model. So you can identify if the cable trays are in the wrong place. You can identify if the pipes are clashing with the ductwork. You can find lots and lots of issues. The one thing that we did on this project, which is different from the previous ones, is that all of these clashes that would normally be left in Navisworks, we saved all those issues in Navisworks, which we've done many, many times in the past. So Navisworks is our coordination tool. And then we took those issues and we actually published them onto a cloud. So we put them onto a tool called BIM Collab. So you don't have to have the model and you can actually see what the coordination issues are. More importantly, with BIM Collab, it allows us to issue them to particular people in particular organizations. So we can make somebody responsible for them, and then we can give them a deadline by which to fix it. So on this project, we went from just doing clash analysis and writing clash reports that nobody looked at to actually using a tool on the cloud where we could actually assign responsibility to individual engineers, individual architects, and get them to resolve problems within a certain time frame. So this tool became very, very important. So if you've not heard of BIM Collab, it's definitely worth looking up. And there are a number of other tools out there that do some similar functions. The key here is make the issues as available as possible to as many people as possible. Now, the backbone to all of this, and I mentioned this earlier on, is the common data environment. So on this particular project, we're using ProjectWise. We have staff in Kuala Lumpur, we have staff in Singapore, we have staff in Hong Kong, we have staff in the Philippines, and we have staff in India. While we have co-located engineers leading the design, all of their supporting teams that were doing the engineering calculations, a lot of the modeling work, a lot of the drawing production, a lot of the design management, they were being done offshore. So we needed a platform that we could link all these locations together. So this common data environment, or CDE, which is another common BIM term, we use ProjectWise. We had over 700 users on the platform. We had 75,000 model files, and we had over 250,000 drawings. So if you remember on Cathay cargo terminal 10 years earlier, we had 2,000 drawings, and this one we have 250,000 drawings. So the actual systems and the structure of the systems and the systems to be on the cloud, we have to rely on technology like Microsoft Azure servers. We have to have basically backup servers locally. So we've actually got a replication server in the main office. So overnight, we would actually get all the files set up in the main office based on the cloud information. So there's quite a lot of technology involved. But the most important thing here is this notion of a single source of truth. The only information that was valid on the project at any given moment in time was the information that was on the ProjectWise server. So if you had a model from somewhere else, or you'd received it by USB, or someone had emailed you some PDFs, they were not valid in the sense that they may have been superseded or they may be incorrect. So the only valid information was on this particular CDE. And just to give you a sense of it, you can store any digital information that you want on a CDE. So that can be models, that can be reviews or reports, it can be these issues trackers, it can be drawings, it can be schedules. And then most importantly, it can be all the asset information management, which I'm going to show you. Now, just to give you some bit of a slap in the back for our team, this is in the middle is Mr. Nick Moorcock. Nick was the lead for Gamuda for the BIM exercise on the project, and Nick and his team got certification last year from the BRE as being a BIM level 2 competent contractor for all of the process that I've just showed you on this particular project. So we've actually complied pretty much to its entirety on PAS 1192, and now we're actually working on upgrading our skills to ISO 19650. So again, if you don't know what these standards are about, if you don't know what the requirements of these standards, now is a good time to start learning about PAS 1192 and ISO 19650. Skip that. So I'm going to give you a couple of tips as engineers. Actually, I need to go back. In order for these technologies to take off in any organization, excuse me one second. There are 3 questions that you should ask. What do I need to do? What does my boss need to do? And what do my colleagues need to do? So in order for something to be successful, this is a team sport. So you may be tasked with identifying what the business case is, and you may be tasked with finding out what the right technology is. Once you've done that, you need to understand what your boss has to do to keep the whole thing going. And then you have to understand what your staff, what your colleagues could be in other organizations as well, not just your own organization. What do they need to do? So let's look at some examples. Oops. So I always say that you need to take ownership. You need to be responsible for your own ideas. So you identify the problem, you come up with a way to use or adapt the technology or to address that problem, and then you develop a budget, a plan of action, and you roll out how the innovation is going to take place. And basically you own it. So let me show you an example from our team. This is Mr. Pois. Mr. Pois is the head of surveying. He didn't need to be told about laser scanning. He found it himself. His problem was not being able to get the information for the staff quickly enough. Surveying is a very time-consuming, it's a very skillful process. It requires a lot of staff, and it takes a long time to capture a lot of information. So Mr. Pois had started using laser scan point clouds, and then his team, and you can see Phi is here in the middle, we trained the surveyors how to use drones to do surveying. So here you can see an example of Phi, one of his colleagues. First thing to note here, there's always 2 people involved. There's always the operator for the drone to look after the actual operations of the craft, and then there's a safety spotter. So while he looks like he's staring into space, he's actually keeping an eye on the surroundings of what's going on. And this is a great picture. This is the Petronas Towers, or KLCC as it's known here. If you want to get more information on drone surveying, another plug for LinkedIn, you can find some good articles on LinkedIn, so I'm not going to go into the detail. But the most important part to here is FIS took on the ownership of the entire drone program, and now is responsible for the purchase of the drones, the maintenance of the drones, the training of the staff, the operation of the drones, and he's created an entire niche for himself inside the engineering surveying team with the use of drones. And FIS and Pois did such a good job that when myself and Nick went off to Singapore last year, we actually picked up an award for the use of drones and reality modeling. They put me on stage because I'm a good public speaker, but I can't take any credit for the technology and the use of technology. These guys did all the hard work. So you've got your idea. Now you have to validate the idea, approve the budgeting, and acknowledge success. That's your boss's responsibility. So that could be, if it's a small company, the managing director or the owner. If it's a large organization, that could be your direct line boss. It could be the CFO, the CIO, the CEO, whatever one you want. But you got to get a validation of the idea. They've all been around as long as I have, 20, 25 years. If you have a good idea and they can see value, they'll validate it. They will approve the budget. And then at the end, they need to acknowledge your success. But you need to have an approved budget. So let's look at another example of this. So one of the other things that we're now doing is we're looking at removing as much paper from our sites as possible using digital forms. So a lot of you will have seen people using iPads on site, but if you look carefully, you'll still see lots and lots of paper. So what we wanted to do is we wanted to get rid of all the paper forms of our construction projects. So the guys came up with this idea of paperless construction, and they've ended up developing a system and training up a team of people, which is, in my opinion, an absolute roaring success. They've deployed hundreds and hundreds of tablets across the sites. They've thousands and thousands of users of this platform. It's used on every day on every one of our projects, and it's used across all the different disciplines. So the team that are behind this is a very large team of people that are behind this, but 2 key guys in this are Tony Joseph, who's our development operations manager, and David Kong, who's head of our QA/QC. Those 2 guys have developed and trained and executed some of the best digital implementation that I've seen. They've gone and they've looked at each different department. So whether it's the health and safety department, the quality department, the progress approvals department, the engineering department. They've looked at every single department across every single station, and they've come up with forms on the iPads and tablets to replace paper. And it's been a huge success. And what's interesting on this, the lessons that were learned in developing these technologies and the use of the tablets, we've used that same technology to manage the COVID-19 pandemic on our sites. So now if you come onto one of our construction sites, you will see firsthand these tools, because you will not be allowed on site unless you've been given granted an access and have a QR code. So you will need to have a QR code, which will trigger an entry into a database of your arrival at site, where it will track the GPS coordinates of the device, so it knows exactly where you are. It will basically record your name, it'll record your time of entry, and then we'll record the temperature using a thermal sensor at the entrance, and that will get logged into our database. So we are legally required to monitor the temperature of all the workers entering our sites for obvious reasons. And then we're using the same system for tracking all the health and welfare checks. So we're doing testing of all of our staff. So we're doing PCR testing, RTK testing. All of that testing is being logged on the same system. And now we're using that same system for a number of other projects. So what started off as a digitization of forms has become an immensely successful project. Now, the last thing I'm going to quickly talk about is asset information management. In this case, I'm going to use the KVMRT. And the one thing I want you to get your heads around is the need for a classification system. So there is a uniclass system, which is the background of what I'm showing you here. And very, very quickly, the classification system is what's required to be able to structure the data in order to be able to feed it into any kind of facility management system or asset management system. So if you don't have a classification system, you're not going to be able to move forward. So this is the first lesson that we learned on the underground. So there are 4 levels. The first is an entity level. So in this case, a railway station. That's the easiest one to understand. The next is spaces. So in the world of BIM, you can use the tools to create 3-dimensional spaces. So the 3-dimensional spaces can then be labeled, and then objects inside those spaces will inherit that information. So if you have a pump inside of a plant room, it will inherit the information about where it is. So then when you have a particular system, so in this case, a drainage system, which could be a pump sump system, once all the systems have been properly categorized or classified, we can then determine which part of the system is there. We can determine if the system is complete, and then we can link that system into the database. And then ultimately we get down to the actual individual products that are in that system, where it could be a cooling tower, it could be a chiller plant, etc., etc. So each of these systems has to get identified down to this level. So this is something that the engineers have to input into the design models during the design process, and they have to follow a very strict coding system, otherwise the whole thing goes to pot. So again, if you've not seen these classification systems, and if you're listening to people talking about implementing PAS 1192 or ISO 19650 or asset information models or employers information requirements, this is one thing you have to get your head around. Without classification, you can never meet those requirements. So the last thing in terms of getting this to work is the overall team responsibility. So you've come up with your idea, you've proved it in a proof of concept, you know it works, and you know that you've got a budget for it. You now need to work with people who are willing to change. So in your organization, there must be, and I know there are, many, many engineers, many technicians who know we can do a better job. So you have to get them to attend training. They have to learn these new systems. They have to be willing to change their ways of working. And you have to get them to provide feedback, suggestions, ideas. And then you can commit to making this change in the overall business a success. And the trick to this is make this as simple as possible. So whenever you come up with an idea, it has to be easy to implement, and it has to be easy for other people to adopt. If it's too complicated or it's too sophisticated, it's doomed to fail without a lot of hard work. So I'm going to skip this for a second. So this is how we create digital champions. This is how we create people who are going to lead the industry forward from 2015, 2025, and 2030. Take ownership of your ideas, invest in creating an innovative culture, and when you are successful, celebrate that success. So that's the end of my presentation. At a glance, I can tell we've got a few questions, which is great. So I'm going to invite Mr. Chu to come on, and he is going to help us do a Q&A.
Yes, thank you, Mr. Ronan. Indeed, it's a very, very enlightening information that you have been sharing. Yes, BIM. I strongly believe nowadays, no industry in the world remains untouched with digital technology. So having to say that BIM, as far as things are, and again, BIM is an intelligent 3D model-based process. It become more accurate or even more efficient, especially when you're talking about complex and fast-track projects. Agreed. Yes. Now, survey has been done also there by McKinsey, found that about 75% of the company that adopt BIM reported positive return in their investment. Long story short, we must change. To change for the better, I mean, we all know the power of BIM, the beauty of BIM. So yes, no shortcut. Change to deliver value for our client and to the project. That should be the correct message that we will need to bring across. Okay, yeah. Good. Where we are. Question is, let me see.
We got some questions.
Where is?
So I can see a couple of questions. Yeah, your signal got a bit garbled there, I'm afraid, Chu. So I've got okay. I'm looking at the question window here. We had a problem with sound earlier on. Darren Lamb unfortunately has left. I'm not quite sure what happened there. Daniel couldn't see the screen, but I'm sure he's got it figured out. So Daniel has made an observation which is very valid, that this technology has been used in the auto industry for the last 35 years. 100% agree, Daniel. This is not new technology. So the challenge with this technology is not whether or not it can do the work. The challenge is that in our industry, we work in silos. So we have architects working on a fee, okay. We have engineers working on a fee, we have contractors working on tenders, we have subcontractors working on hard bid prices. We don't have the same culture or processes of the auto industry where they have a much more joined up supply chain. So when I looked at the auto industry years and years ago, the big takeaway was that if you're a manufacturer in Japan and you're making parts for Toyota, you're probably making parts for Honda and you're probably making parts for somebody else, but you're making those parts to their specifications and their design requirements. And it is probably been driven by a 3D process. So the car industry is far more digitized in its supply chain, and that is what the construction industry ultimately is going to have to get to. If we're going to be successful, we have to break down these silos and find these digital connections, but we still have a long way to go. Next question I've got here is from one of my colleagues that worked with me on the MRT. So Lutful, it's nice to see you joining us. He's got 3 questions, which is not unusual for Lutful. So the first question is, do we use one model where we convert design models to construction models, or there will be 2 models, which is the design model built by the consultant and a construction model built by the contractor? Okay, so this is a really interesting problem. So in the world of traditional tendering, where you have an architect and an engineer appointed, they do their design, they come up with a tender package. When you then go to construction award, the models are sometimes not fit for construction detailing. So it's easier for the contractor to make their own models for their own purpose. And in so doing, you end up with basically a design model which becomes separate from a construction model. That's not ideal. So for the underground project, the models have been shared with the contractor all the way through the process. And where changes need to be made to the models are made by the designers to the models for the contractors. And only when we get to trade packages do we actually send out the models for them to use. So the mechanical electrical models that designers have done are passed to the mechanical electrical contractors for them to add detail to. So again, it's a design and build collaborative form of contract, so it's much more suited. So one of the challenges with BIM is difficult to get to work in a more traditional form of contract where it's hard bid or competitive bid. It's easier to get to work in a collaborative form of contract. Second question from Lutful, are CSD drawings still relevant in the construction industry, or we can use BIM models as a guide on site for construction? Brilliant question. The currency, according to the contracts and the lawyers, is still 2D drawings. So in order for us to form valid contracts, valid agreements, and for us to be able to determine price change, quantification, drawings are still the currency. Until such time as we can develop accurate and detailed enough models at an early enough stage in a project, that's how it's going to stay. And again, this goes back to the point of, do we have an argumentative form of contract with risk allocation and risk shedding, or do we actually have a collaborative form of contract with risk allocation in a fair manner? So until we actually change the way we collaborate and until we change the way we contract, we're always going to need drawings as basically a form of contract. And then the last question is the IFC classification important for asset classification? That's probably a bit muddled of a question. So the uniclass classification is what gets put into IFC information in the models. So the IFC classification is essentially the same as the uniclass classification. I hope that answered the question, Alfo. The next question we have is from Mohammed Abdullah. And Mohammed is, what are the standards you mentioned earlier? Okay, so the standards are PAS 1192, PAS 1192. So I'll tell you what, let me do this. Give me 1 second. I've got a little slide here with them all on it. So hang on. This one. It's much easier to show you than to actually try and call them all out. So it is this one. And I have to do show my screen. I have to do, oops, what do I have to do? I have to do this. Sorry, bear with me here. I'm still trying to figure out. It's over here. So Mr. Mohammed Abdullah, go. So let me show you this really quickly. This is the first standard, BS 1192 from 2007. This is for the actual, this is the basis for CDEs. So if you want to learn from where it started from, go and look at the CDEs. This is where it came from. The famous BIM standards, PAS 1192 Part 2. So this document was written in 2013. This is the one with the famous BIM wedge. This is the one with all the information about the employer's information requirements, BIM execution plans, and all the processes around tendering and appointment and verification of services. Part 3 is to do with information management for assets, which is what we're using for the asset information. Part 4 is to do with CABE, which is a specific requirement for the UK for the use of CABE for collecting asset information. Part 5 is to do with security, security of information, not the security of the actual built asset, but the actual security of information for the asset. And Part 6 is to do with health and safety, using BIM for construction health and safety audits. And again, it's a very UK-centric document. So the PAS 1192 suite are a set of British publicly available standards. The only difference being that the original BS 1192 was a traditional British standard. The reason that they're all publicly available standards is to make them easily, readily available to the market, and to avoid any obstructions in actually using them. These have come out between 2013 and 2018, and subsequently have been developed into a suite of ISO standards. So the 1192 suite of 1192 1, 2, and 3 has become ISO 19650 Part 1 and Part 2. And essentially, these are now a global standard. So they're going to be used for work in Singapore, they're going to be used for work in Hong Kong, they're certainly going to be used for work in Malaysia in the coming years. And these are documents that you're going to have to understand and learn. But essentially, the principles don't change. So I could apply ISO 19650 to the MRT project. I could probably have applied it to the Cathay Pacific Cargo Terminal project 10 years earlier. Obviously not to the full detail, but essentially, these are the key documents that everybody needs to be familiar with. So whether it's PAS 1192 or whether it's ISO 19650, these are the two main BIM standards. And then obviously there's a lot more besides that. So hopefully, Mohammed, that answers that question. Let me go back to the chat box. I think we've lost you. I'm not sure if he had a bad connection or I had a bad connection, but Mohammed, I hope that answered your question in terms of standards. Daniel's agreed to my comment. Great. Okay, so we've got another question here from, let me see if I can get the names right. I do apologize if I pronounce your name wrong. There's nothing worse than being called the wrong name. I've been called Roman, I've been called Ronan, as in Japanese warriors. I've been called Rohan, I've been called Ron, and I've been called expletives, so which I'll go into. But so the next one I've got here is actually from Ivan Sadikin. I hope that's correct. Just curious, in your recent projects, do your client have an EIR or BIM requirement, or do you still need to help them define what kind of BIM implementation? Brilliant question. So on the MRT project, MRT worked with Arup during the preliminary design, and they developed a very, very good, very well considered employer's information requirement or BIM specification. So we started from a very solid position with the actual tender documents. And that was somewhat from learning on the first project on line 1, somewhat from the learning of projects in the UK, particularly Crossrail. But essentially, the client did have a reasonably good EIR on that project. Now, what they didn't have was a full understanding of the asset information requirements. So there was a lot of room for wriggle around the asset information requirements because they just didn't understand how it was going to work. So we did have to work with the client, and we're still working with the client to help define and collect and structure that information in a way that's valuable to them and is not abortive, doesn't involve a lot of abortive works. So there is no project that I'm aware of that has actually got a fully fledged, fully ironed out, fully detailed employer's information requirements. It is a team sport, and there is going to have to be collaboration between the owner, the designers, the contractors, and the supply chain, because ultimately the information required to run the facility doesn't come from the architects and the engineers and the main contractors. It comes from the supply chain, the people who install the systems. So there is no short circuit to this. It's an ongoing process. But yeah, good question, Ivana. So Lutful's happy. He's acknowledged my response. So that's basically all the questions we've got. I don't know if we've got any more questions. As I say, if you do want to keep in touch, do look me up on LinkedIn. It's pretty easy to find me. So there's not too many Ronan Collinses on LinkedIn with this style of haircut. In other words, no hair. And I think at this point we can hand back to the organizers, but I'm not sure where they're at. So
that's all right, Ronan. I'm here.
You're here, great.
Yeah, I'm here. Don't worry. So that just about wraps up the webinar for today. So I just want to thank everybody who has attended and everyone who has presented a little something for us today, especially you, Ronan. That presentation had a lot of information in it.
Yes, a huge dump.
So yeah, I just want to thank everyone for attending and joining us. If you have any feedback, please do send it through. The video will be uploaded to YouTube later on today. If you have any ideas for future webinars, or if you think you can present one yourself, please do let us know. But that's it really, so I'll wrap up with that. Thank you again for joining us, and hopefully we'll see you all again next time.
Yes, thanks everybody, good night.
Yep, thank you.